let's go get started. Okay, so Bellward, let's take a look at, I don't have my book with me. Anyways, the first thing that you had to do was take a look at which ones were sums, right?
Yeah.
So let's take a vote on the first one. Is that a sum? First problem on your Bellward, is that a sum?
No.
42 minus 12?
That's the subtraction.
That's the first
That is
one.
a subtraction. I just wanted to put out a word of caution. Technically, if you want to get into the nitty-gritty of it, it is an addition problem. Because you're adding the opposite of a number. You're adding the opposite of a number. So, yes, it could be considered an addition problem, okay? Second one, definitely, right? That's a straight up, that's a plus sign. Addition symbol, 27 plus 6. The last one is multiplication. If you wanted to get technical, you could, because it's multiplication is simply repeated addition, but we're not talking about that. We are definitely multiplying here. And then the last one is division, which is repetitive subtraction, aka repeatedly taking away the opposite of something. What's that? You don't think I'm recording? Are you monitoring me?
Yeah, was that a notification? That notification squad?
Notification squad? Stop streaming. No, it's good. Let me check here.
Oh, heck. Chamber for
Check.
follow me on Instagram.
I don't know.
Shout out to Gmail Day.
It might not, so.
It says you're live.
It says I'm live, huh?
Yeah, you are recording.
Yeah, we're live, we're good. I got the ugly screen up there. All right, so now there was some vocabulary on there. The first one, of course, was sequence, right? We talked about sequence. What is a sequence? It's just an ordered list, correct? Kind of like the alphabet, A, B, C. We've talked about numbers. Well, actually, our number line is an ordered list. It's a sequence, and it has a common difference of 1. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then that was 9-1, 9-2, 9-3. Let's talk about 9-4. 9-4, we're starting with this thing called arithmetic sequences. Sorry, arithmetic series. Series. And what is an arithmetic series? It's right there, the definitions.
It's a series.
The number of objects that happen in order or one after another.
Okay. So, when you know two terms and the number of terms in a finite arithmetic sequence. So, you have a sequence, and there's some important words up here, and it's finite. What does finite mean?
It ends.
It ends. Infinite means?
It doesn't end.
Doesn't end. Finite, it changes the way we say it for some reason. I'm sure it has to do with all those rules of English. But if you have a finite series and you know a couple of numbers in there and you know how many there are, then you can find the sum of them. Make sense? And that's what we're doing today. So, lowering down the objective today, we're just doing a bunch of addition. Yay! I can plus.
Can we
Yeah.
color too?
He's like, yeah! I want a plus. All right. And if we know those things, then here's how we would plus them. Okay, this should be in your companion, so you guys can take those notes there. If I know the first one and I know the last one, then I can, and how many there are, then I can add them, divide by how many there are, and I would find their sum. Let me give you an example. And we'll make it something simple so it kind of makes sense. I've got this sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? I want to find the sum of them. Now I can sit there and go 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, blah, 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 blah. It's exhausting, okay? But you know what? I know that there are 10 numbers there, don't I?
Yes.
So that is my n. That means that I take 10 divided by 2, and I'm going to multiply it by the sum of the first one and the last one. 10 divided by 2 is 5. That sum is 11. When I find the product, 55. Look, the sum of the first 10 numbers is 55, and I'm done. Yeah, that's awesome.
Why is it divided by 2 again?
No, that's math magic. So go ahead and write those notes down for a second.
Manios. So why is it divided by 2 again? It's just always divided by 2 or no?
Yes, it is always divided by 2. Let me tell you why, guys. Check out this pattern. This is really, really cool. Obviously, this is 10, correct?
Yeah.
Obviously, that's 10. But how much is 9 plus 1?
10.
How much is 8 plus 2?
10.
How much is 7 plus 3? How much is 6 plus 4? Oh. So, some number on the left with some number on the right will always match up to give you what's supposed to be the outer kind of sum total. Now, that's not completely accurate, but that's the idea. And that's why we divide by 2.
Even if there's an odd number?
Yes. Because even at some point, if the sequence, remember it's a sequence, so there's an order to it, correct? So yes.
Yes, I got a
Now.
question for you. How do I qualify for government grants?
That's not a question for right now. But I think you have to be very low income, or you want to start a new business. You can do that as well. There's a couple of different ways you can do that. So,
So, it does work if it's like 1, 3, 2, 6, 4, 5. So, okay.
So it's kind of like a meter.
kind of, yeah. It kind of is. Yeah. Nice, simple way of looking at it. We're kind of finding the mean of all that stuff. But it's kind of is. What's up? All right, we're good with this slide?
Yeah.
All right, cool. Moving on. Here's what you also need to know. Something else we're going to be doing. Summation notation and linear functions. This is arithmetic series. So arithmetic series, I think you've noticed that they all have a linear equation, don't they? Okay? So, and then the other important thing here is summation. If the explicit formula for the nth term in summation notation. Anybody know what summation notation is?
Some kind of
No, but I'm here to learn. Teach me, O wise one. Is a linear function of n, then the series is arithmetic. The slope of the linear function is the common difference between those two terms of the series. We already knew that. We knew that from 9.1. And so, let's move on. I do want to talk about arithmetic first, okay? When we start doing these arithmetic series, we're going to be using one of my favorite Greek letters called sigma. Sigma. Anybody know what sigma looks like? Not Simba.
Long live the king.
Long live the king. Anybody see a symbol that kind of looks like that? I butcher it. It's not E. That is not E.
Mess up our class.
That is horrible.
That's the symbol that was in the Lion King.
That is
Simba.
that is sigma. Sigma. That is the capital S. And of course, that is going to be not an O. That is lowercase. And I do them no justice. I can't write them for.
What's that?
It's lowercase. It's kind of like.
Is that cute?
Yeah, it does something like this.
Okay.
Okay?
It's like an E.
It kind of looks like a D on its side, but kind of wavy.
That's his head.
But anyways, that's not what we care about. We care about the capital sigma. And so you know, you're going to see that a lot from now on. You're going to see it in probably your trig. Have you seen it in trig yet?
Not yet.
Not yet, but you'll see it in calculus. If you take AP statistics, you'll see it in statistics. And of course, you've definitely seen it here. Now, don't be afraid. Whenever you do that, see that symbol, whether it's in calculus or it is in statistics, then they're just asking you to add some stuff. They're just, yeah, yay, adding. I love the pluses. All right, finding the sum of a finite arithmetic series. You guys ready? So I've got this here. I want to find the sum of even integers. The even integers from 2 all the way to 100. Okay? So I want to find the sum of all of those. Well, let's think about that for a second. How many numbers are there?
a lot.
Well, we only want the even ones. So how many evens from 2 to 100?
50.
There's 50 of them, right? So we're going to take our formula, which is n divided by 2, add the first one to the last one. So I've got 50 divided by 2, 2 plus 100. So I'm taking 25 times 102. So what is that product?
You go cheaper.
I'd have to say about 625.
I divided.
2,500.
How much?
2550.
2,500.
It is 2,550.
Oh, no way, I guess.
2,550.
Yeah.
No, it's not 2,550.
No, that's the thing that I just said.
No, you just read that.
It's 2,550.
And it's just math.
Don't make me send you to Algebra 1. Oh, sorry. You guys good here? Let me see those thumbs. Up, down. All right, cool. No. Okay, can I change the slide then?
Sure.
No?
No. I bet neutral. What does this mean? If your thumb's
That means you need to go get that check.
Stop. Stop. That's disgusting.
Ow, super, have you never done that?
No, I don't do that. Don't.
No, dude. There's a kid named Dawson and Ben. He goes.
Oh, yeah.
All right, moving on. Thanks for telling me. Here we go. Here's the next one. I'll give you 3 minutes. I want you to find the sum of this. Actually, that's too much. Give you 2 minutes.
Make it 1.
2 minutes. Okay, 1.
Are you serious?
How about 30
And then
seconds?
Nick will tell me what the answer is.
Yeah, put it 1. Put it 1.
30 seconds.
1 minute.
20 seconds. 50.
Go ahead, Nick.
About 58.
Got 56 seconds. Go.
Hey, you just did by 5, bro.
I'll let Nick do it.
What is the sum of the infinite? Oh no, the finite. It's 99. So, 4 to 99.
I'm going to come around and...
Isn't it 96?
I'm actually going to reset this timer, guys, because...
It's 96 numbers, right?
I know, I'm sorry.
96 numbers. 96 numbers.
No, it's by 5, so it's 5.
That's the way.
Add one. Ooh, I got you.
It's 48.
Yep.
Wait, Mr. Munoz.
4,000.
Right?
You got cheese. I know the answer.
41? Yep. That's exactly what I said.
Wait, what did you say, Mason?
About 10 of those.
I told you that's easy.
Right.
You do that? I don't want to know cheese. Did he do that? And then
You add the dots plus the numbers. Dot, dot, dot. That's a symbol for
Mason, are you serious?
Oh, it's right here.
No, no.
Last number. Oh, is it divided?
Because 100.
Where'd you get the plus 3?
100 divided by 2 is 4,000.
Forgot to square root it.
I thought they... I'll tell you guys right now.
Forgot to square root it. Oh, we're not teaching how to do it.
Guys, stop for a second. Thank you. If you're getting decimals, you're wrong. I'm sorry to say it that way. Take a look at those numbers.
See him.
Are any of those numbers decimals?
No.
Then how will we ever get a decimal by adding just integers?
A decimal like at all.
It should not happen, right?
I guess.
I didn't
So-
get decimal.
Now, I left you guys because I like the discussion. You guys are having some good talking here. I don't know. But let me get to this before it annoys me. You guys can probably go off. Okay. So, let me show you.
Let me show you.
Go.
No.
Let me show you how to get that number and be right about it, okay? Because sometimes you're going to get some funky numbers at the end. And we're going to make assumptions that we shouldn't make. I have to admit that I made some of those assumptions earlier in the day.
Oh.
So let's do this. You guys ready?
Did it wrong.
Now, in order to do it, now for starters, if anybody had this, you found that it was 20, right? Oh, look, the example's right there too, Mr. Munoz. And it's 20. But stop with those pencils down. All eyes up here. All eyes on me. Ready? In order to find out what number that really is at the end, I'm going to have to find its formula and then solve for that. It shouldn't take me too long because I know that the common difference is how much?
5.
It's 5. So that means I'm going to get 5n. How did 5 become a 4?
But it's subtracted by.
I took 1 away. Look, that's my explicit formula.
There you go.
So I asked the question to my algebra. Hey, algebra, how did 5n minus 1 produce 99? So that means I'm going to go plus 1, plus 1. I've got 5n is equal to 100. And once I divide by 5, that means that the position of that n was 20. So this is a sub 20. So now I know how many numbers there are. How many numbers are there?
20.
20. N is 20. So now I can go back to that formula. I'll use another color here because.
My hand hurts.
Wait,
Whoa.
what?
Where does your head hurt? Why?
Why did you have
Yeah. In the first place, like why?
Yeah, like what's the...
We're trying to find out how many numbers there are.
Oh, that was oh.
Now, a bunch of people have different ways. I'm telling you, I was doing it that way, second hour, third hour, and they were not accurate all of the time. And I'm showing you how to get it correct all the time.
Do we always, like, whatever number it is, do we always add something or subtract something?
Yes.
And get it just by 5?
Because what did my instructions say at the beginning? Right here. If the explicit formula for the nth term of summation notation is a linear function, then the series is arithmetic. So if the series is arithmetic, then its explicit formula should be linear. Linear. AK AX plus B, or MX plus B, however you want to say it. Okay? In this case, not AX plus B, but DN plus, I'll call it some constant. I forget what they call it. Common difference, N plus something. Or minus something. Does it ever have to have that? Does it always have to have that? No, not really. You could probably add nothing to it. So back to my objective. I did all that just to figure out how many numbers I had at the end. And you're going to want to know how to do that. Okay? Now I can find your sum. Okay? Because I know how many there are. How many were there?
20.
Oh, JK, smiley face, lol. There's 20 numbers. So 20 divided by 2. The first one is 4. The last one is 99. So I've got 10. Oh, that's horrible.
10 times 103.
10 times 103, which gives me 1030. And that is the sum of all the numbers from 4 to 99, skipping 5.
So you put the amount of numbers divided by 2. Okay, hold on.
N divided by 2, plus the first one, multiplied by the sum of the first and the last. That's your formula. I'll give you guys a few seconds to copy that over. Ah, why for you lock me out?
Cancelled.
Me not like you, cause I do.
Okay, let's think about that. I mean, it's in the hands of Batman, bro.
Bahala na si Batman.
That's it, Batman.
But you got two different.
This one's coffee, this one's water.
Okay.
Did you not know that coffee makes you thirsty?
I don't drink coffee.
Did you not know that I'm
Thirsty.
You can both at the same time.
Yeah, just pour them together, and then that's one drink. So then you're thirsty, but you're
They need
being
some watered down coffee.
dethersitized. That's disgusting.
Sounds like we're done copying, so I'm going to change the slide example.
Hold on.
So you do the amount of numbers divided by 2 times the first number plus the last.
Beautiful.
Okay, I'm done.
Well done.
Good
I
job.
fixed my answer. I'm good.
That's a very sweet formula. What's that, Lars?
I think you're supposed to put, how do you get -1 5n? I know where you got 5n, but how do you get
Well, here, and I'm glad that you asked that. I'm going to move some of this real quick. Because I got it from my explicit formula that's right there, right? Now, you're okay with this part, right?
Yeah.
Now, I have to ask myself this question. Remember, if I'm writing explicit, I can only have n, correct? So if I make the assumption, hey, what if what if n equals 1? That would give me the a sub 1 position, right? So my question to myself is, if n was 1, then that would be 5, correct? Because 5 times 1 is 5? How does 5 become 4?
-1.
I take away 1, which means that should have a -1 there. Okay, and we'll do that again. We're going to do it again at least 2 or 3 more times. 2 or 3 more times. That's correct. All right, moving on. I'm a little conflicted, but I'm going to show. I'm going to try it this way because last hour I was jumping around, but I'm going to do it this way. Here I have a sequence. I have a sequence, and I need to write this in what's called summation notation. Okay? Thanks for putting your phone away. I'm going to first find the explicit formula. What is my common difference here?
4.
4. So I've got 4n. Now, if n was 1, I have 4, right? How did 4 become a 7?
3.
So there's my explicit formula. Let me check if it works, okay? This is the third number, correct?
Yeah.
A sub 3? So that means A would be 3. So 4 times 3 plus 3, that's, how much is 4 times 3? 12 plus 3, is that a 15?
Yes.
It works. It works. So my explicit formula is that. Okay? Now, I need to know how many numbers there are. Okay, obviously this is a sub 1, correct? Because what I want you to do is to add all of these values from where n is 1 up to how many there are. How many numbers are there? Oh, not so simple this time, is it? Not so simple as saying, oh, it could have been 100. I'm divided by 2. I got 50 numbers. Okay? So, let me show you what I'm going to do. This formula works, does it not?
Yeah.
So I'm going to ask my formula, hey, when does 4n plus 3 equal 207? When does 4n plus 3 equal 207? So I take away 3 to both sides. I get 4n is equal to 204. Divide both sides by 4. That means that when that happens, n was 51. That means that this is a sub 51. Tra-la-la-la-la. I want you to go from a sub 1 all the way up to a sub 51. Now this probably means nothing to you right now because you don't understand how it works. So I'm going to jump. I see your faces. Like, okay, what does it mean? I want to jump to here, finding the sum of a series. Okay? Here's my first example. This is already done. All the work is there. Let me tell you what it means. This is a formula. Here, do I have the sequence? Do I know what the sequence is? I don't. I don't know what the sequence is because they don't give it to me. But I can find it. I can find it if I follow their rule. That is the rule. And they want me to start at 1. Watch what I'm going to do. 5 times 1 plus 3, how much does that equal?
8.
That equals 8. That, my friends, is a sub 1. Then I'm going to go 5 times 2 plus 3 equals? What number is that? Or that is a sub 2. That is a sub 2 in my sequence. 5 times 3 plus 3 is 18. That is a sub 3. Then I would go 5 times 4 plus 3 is 23. That is a sub 4. You get the picture, right? How many times am I going to do that?
70 times.
Yeah. 5 times 70 plus 3. That's 350? 353. And that, my friends, would be a sub 70. At this point, I would get all of these values and add them up. But you understand what's happening with summation notation? They're saying, hey, this is how I can get every single value, every a sub n, if you will, and we're going from 1 to 70.
So if the first number was 4, would it be n equals 4?
No, because in the sequence, no matter what you start with, what do we designate the name to that? A sub 1,
Okay.
because it's in the first position. Okay. Now you can say a sub 1 equals 2,
Oh, yeah.
right?
Yeah.
But that n represents position.
So if it was like that, and like, then that would be 2n, right? Like that.
Yeah, my explicit formula for this sequence?
That would be 2n. What would you do for, like, how would you do that for that?
Okay, so you want me to take this. So if I have 2, 4, 6, how far do you want me to go? Pick a number. Make it even.
12.
12? Okay. Dot, dot, dot. Obviously, my explicit formula is simply 2n, correct? I don't need to add anything or take anything away. So I have 2n, and I want to find the sum of all that, is what you're saying?
Yeah.
So I would say, I would have to tell you, you need to add all of these a sub n's, starting with sub 1, all the way up to, well, how many are there? 6.
So would you need to like add all of the numbers together?
Yeah. Oh my God. Are you seeing how much time that's going to take? That's anybody think like, man, that's going to use up like, I'm going to do my homework on tissue paper. Just roll it out, right? The important thing right now is that you understand what this is asking. So let me,
Yeah, I know.
what does this tell me to do? Thumbs up, thumbs down. I understand this. I don't understand this. Are you serious or not?
It's a simple.
No, I wasn't here.
Okay. All this is telling me is how to get all these numbers back.
Oh, so it's just.
Okay. That's all it's doing.
Let me look at this for a little bit.
I'm still kind of confused on like, okay, so I know that 1 is the pattern of it, like n is equals 1. Well, what if it was like let's say example, like what if n was 3?
Okay. If I do have a pattern, then and n was 3, then I would not add those two, because I don't want to start at n equals 1. I want to start at 3 and then go to 70.
Six.
You cross it out.
Whoa.
Why would you, if it was n
He said, what if n was 3? Right here. If n was 3, could I produce n sub 1?
No.
Sorry, could I produce n equals 1?
No.
Yeah, I could, because I did it.
What?
Could I produce n equals 2?
Yeah.
Yeah, because I did it. But his notation is telling me start it when n equals 3. This is a sub 3, isn't it? What is the n to a sub 3? 3. Start at the third one.
Wait, so if it was n sub 3, would you have to go n sub 6 next, or no?
Well, this is telling me to go from 3 all the way to 70.
So no?
So it'd still be the same exact thing, you just would start differently.
Correct.
Okay.
Now, let me ask you this question: Can I produce a sub n's to this beyond 70?
Yeah.
Yes, I could. I could go and find 71, 72, 73, but this is finite. It's telling me from where to where do I want to go. I want to start, in this case, in the first one, from a sub 1 all the way to the 70th one. But I don't have to. I can pick where to start and where to end. As long as that sequence is finite, I have a definite starting point and a definite ending point, then I can add up whichever ones I want in that. Is that another question? Anybody else? Go ahead.
So all you're doing is plugging them in.
Yeah. Yeah, it's what this is. What this is a compressed. Think about this for a second. Would you want to write me a list of 70 terms? No. I can do that. That's more manageable, isn't it? But this is telling me exactly the same thing as writing a whole list of them. And if I want to know any one of them, I plug the position into the formula, spits out the number. What do you got?
Okay, not in a contradicting way, but why do we do this? Like, how does it help us?
There's actually a big, how do I say this? There is a big field for this, okay, with Riemann sums. When you get to calculus, you're going to be finding areas under curves, which is kind of a statistics things as well, which is areas under the curves. When you want to make predictions, you need to know. How many people have seen this bad boy before? What's it called?
Climax thing, Bob.
Oh, wait. Okay.
No. You guys ask for this all the time and you don't know what it is. How many people say, hey, can you grade that test on a curve?
Ah, it's a curve.
Well, more specifically in statistics, it is a curve. And that's what we mean kind of when we say, can you grade on a curve? But more specifically, this is what we call a normal curve. And the beauty of this normal curve is that it's symmetric. Okay? And in math, what we're doing, and especially in calculus, because tell me this, how do you find the area under this curve?
Numbers.
Math. Let me show you the cheat sheet behind this, okay? What they'll do in calculus is they'll take little rectangles. Oops, I missed that one. Totally missed that one. Let me see here. So they take rectangles and they try to fill in the curve as best as they can to kind of figure out what goes. Okay, you see that? You see all our little rectangles there? And what they do is they add them up. Now, is that accurate?
No.
It's not, right? Because there's gaps everywhere?
Yeah.
I'm not doing a calculus lesson. So how can I fix this problem?
You fill them triangles.
I can use triangles?
Curvy triangles.
No, I can make the rectangle smaller, couldn't I? Here, think about this. If I made my rectangle smaller,
They have to be like infinitely teeny.
hold on,
Oh,
stop.
okay.
Shh. Obviously, you agree with me, right? My rectangle will have to be smaller. But then you made a fantastic point. What did you just say? The rectangles would have to be infinitesimally small, correct?
Infinitely
Hence, the sum of a series.
Whoa.
We would have to add up all those little rectangles, wouldn't we?
The infinite values.
Formula that would give you the shape, and then how much of the curve do I want?
So is it infinite or finite?
It's finite and infinite. The word is infinite. If it doesn't stop, it does change the way it sounds. Okay, and if you want to say finite, that's, or I don't know, that sounds weird. We say finite for but have I answered your question? Okay, in statistics, this is going to be very important, and we're going to do statistics right after we do this. And statistics is my thing, so we'll get there. Okay. Go up one.
So I see how to do it, but how do you like? Get
Oh, that's pretty sloppy.
What's
What's
that?
that?
Some easier than like
Like just like adding all those.
yeah.
What? You want me to show you an easier way of doing this?
Yeah.
You don't want to sit there and add them? How dare you? So, if you want to find the sum of all of those without sitting there and writing them out and doing it, we're going to use our technology. Everybody got a calculator in front of them? Okay. Here is one remodel. Sorry, here is a summation problem. Here's a summation problem, and we want to find the sum of the numbers from a sub 1 all the way to a sub 70. So we want to add 70 numbers here, and this is the formula to get them all. We're going to go here. Oh. Clear this up. All right, you guys ready? Find here a button that says Math. Push up. And you'll find 0 says summation sigma. Do you see it?
Yeah.
Press 0 and it's going to spit out a template. Oh, yay! I love calculators.
Put 70 up here.
Now, pause, please. With our calculator, you really want to get used to using X because it's a variable button that it understands, correct?
Yeah.
We're going to start from 1 and we're going all the way up to, what was it?
70.
70, so 70. So it's telling me from where to where first, and then I can plug in my model. In this case, what was the model? 5n plus 3. Do I want to type in 5n plus 3? No. I just told it that my variable was x. So that's going to go 5x plus 3. Press enter. And there's the sum. Now I answered your question? Thanks for taking your earbuds out. Yes, sir. Math and push 0. So let me show you this. If you're only getting this, is that all you're getting? I'm not sure what happened there because those are newer operating systems than the one I have. The operating system where I get the top is a 4.0. That's a 4.2. So if you just get that, here's what it wants. It wants first the model. So you're going to have to type in the model. So the model, or explicit formula, if you will. Then it wants to know what the variable is. Okay? So in this case, x. And then starting point. So which a sub am I starting at? In this case, 1. And then I'm going to go to 70. So start and end, and then close the parentheses. Press enter. And you should get, hopefully, 12,635. Yes? All right. Settings. I thought so too, but it wasn't. I'm not sure what setting it would be.
I just switched it from math print to classic.
Oh, it's probably in classic then. You're probably in classic. You want math print on. Math print makes it the new stuff.
Yeah.
Yeah. Any questions? Fist to 5. 0 means I've got it. Fist is nothing. 4, I got this down. 5, I can teach somebody.
I have to teach it, sorry.
It's a cheat.
They say
Yes.
5, me too.
3.5. All right, cool. That is all I have, guys.
Dang it.
We are done.
I get my lunch off.